Number one, input. Number two, these are the things we're going to be talking about. Charging issue, then charging, inputs and outputs. You get? Do you understand?
Yeah.
Outputs. So any related issue with the charging section, input and outputs. Then jumper trick, jumper tricks, power bank. Should I add MP? Yeah. MP3, yes. Power bank and MP3 issues. MP3 issues. Then jumper tricks. Number 3. These are the major things, right? Slow charging issues and solution. Okay, so let's talk about the charging issue. Number one, input section. Of the power bank, right? Of the power bank. This is the section that controls the input current. And input current and voltage. Like I've always said, the voltage is different from current. So now let me just draw a short diagram to this.
Where's the other?
You need power bank today. That new one. Just one body. So this is a power bank module. This is called a module. Do you understand? So let's just draw it out. Then we can now it has two sides. It has two sides. This side, then this side. So let's draw it. So let's draw something like this. Then we have the USB here, right? Then we have the charging port here. We have the USB here. We have the USB here. We have the resistor here. This is a 1K resistor. This is the power IC. Power IC here. This very one. That's the power IC. Then we have the MOSFET IC. We have the MOSFET IC. We have the 1, 2, 3, 4. 1, 2, 3, 4. The power IC. Then we have the LED controller. And we have other resistor here, resistors. Then we have capacitor. We have capacitor. So if this is the charging port, this is the charging port, input voltage 5 volts. We have 1, 2, 3, 4. 1, 2, 3, 4. This is the USB. 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 This is the output, right? We have the output here. Then we have the output here also. This is the switch, right? That's for the this thing good. So we have the this is the input, like I've said. Then we have the MOSFET here. MOSFET. This MOSFET controls the output. This very look at this. This very MOSFET controls the output. So this is the power IC, right? PMIC, power management IC. Let me put it power management IC, integrated circuit, right? So we have a resistor here, 1K resistor.
Okay, this one, this big.
Yes, 1K resistor. Then we have capacitors around it. Then let's see the other side. Nothing is on this other side except for this USB charging ports. So now this is the full for this type of this thing. Can I get another? Okay, I have another one. I want to make reference to another. So now you can see what's the difference between this and this? No difference, no major difference. If you look at it very well, you would see that this has a power IC. There's a power IC here. That power bank that was faulty. Okay, so now, but we removed this already, right? Then here is USB. It has a USB output, input, the switch. Then this is a MOSFET. This is a MOSFET. 5-leg MOSFET. This controls the output. Do you understand? Now, because this doesn't have this, but this is the output for this particular one. So now, as small as this thing is, if it's faulty, this thing will charge in, but it will not charge out. It will not. The output will not work. Do you get it? So, and these are the LED. These are the LEDs. Then we have resistors here. We have this resistor. Then we have this LED as well. So let us take for instance, this thing is, please, if you are watching live, good afternoon everyone, please share the live video so that we can learn together. Thank you. So let's say this power bank now is having a power issue. It's not turning on, or let's say it's charging, but it's not, the output is not working. When you plug, this is the input, right?
Yes.
When you plug this thing, it's working, but it's charging in, but it's not charging out. Now here we have the V bat plus. Here we have V bat minus. Do you understand? So now, if it's charging but it's not, the output is not working, this MOSFET is the problem.
Which one?
This very one.
Okay, yes.
This MOSFET is the problem. Output. It controls the output. That's what many people don't know. They feel is this power IC. It's not the power IC. What the power IC does is to supply current into the module or the PCB. You understand?
Yes.
That's just it. And to regulate it. You understand? So around this place, like I've always said, around the power IC, you must have a resistor. I mean a capacitors around it. This has 1, 2, 3 capacitor, and it has 1, 2, 3. Okay, we have another capacitor, smaller capacitor. These things are called ceramic capacitor. Do you understand? So the best way to test this is this. So I want to confirm if this motherboard, this PCB is working. I put it on continuity mode, right?
Yeah.
So now my red probe will be on the ground, right? Right?
Yes.
Then the first thing I'm going to be testing is the battery connectors, to be sure. You can see. So what is giving us 4.45 excess. This 5 you are saying is excess. So it's a good reading, right? So let me put it back to this place. You can see it's on continuity mode. Okay. If it's on ground, it should definitely be. So now, you see this? It's giving us a good reading. It's on this one. Then also there's this output is also connected to this, some of the legs of this USB. So by the time we begin to trace it, you will know. If you check this place critically, this line, this last line, this last line,
Yeah.
you can see it's connected to this particular line here. You can see. Let's see. Let's see. Let's see. Let's see. Let's see. Let's see. So now let's now confirm if this this module is working or not. I'm going to plug it to light. You can see. So you can see it's working. This is working. So now, this is, we've tested with continuity. Let's on continuity mode. Let's test on direct current. The black probe, the negative will be on the ground. Why you use this to troubleshoot? So then we'll see the voltage is going to be giving us 4.2. Nothing. Why is it or nothing? Because it's on the negative part. You understand? So it's not going to be giving us just one. But on positive, yes. Good reading. Giving us a good reading. No reading. Now, I will tell you why it's not reading on the other side. The reason why it's not reading on the other side is because there is positive and negative to all these SMDs. Do you understand? there is positive and negative to these SMDs. These are called surface mount devices. These things you are seeing. So this, now we've talked about the output, right? We talked about the output. Now let's talk about the input. We've talked about the output, right? So let's talk about the input, how it works. Now, if I would just give us a drama, a dramatic, a graphical illustration rather. Let me give us a graphical illustration to this, so that it should be very, very easy. Don't forget the slow charging as well. Let's say this is 5 volts, right? 5 volts. Current flows to this place. Then it comes directly to on power banks. Current that is coming from this place will be meeting some resistors around this place. Then a power IC. Are you understanding me? Then PIC, power IC, to be hitting it here. It has major, let's say 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So then from this power IC we have resistors around it. Sorry, capacitors around it. Then we have a big, a large coil like a resistor. Usually R100, 1000 also, 1K resistor, or depending on the size of the capacity of the of the power bank, just like this as well. This is a 2000 resistor, 2K resistor. So now, then around it we have, this is the inputs now we're talking about, right?
Yeah.
From 5 volts. Then if it's coming to this place, this is 5 volts flowing. 5 volts is flowing from here. Please see, if 5 volts is flowing from here to this place, then it's coming to this one. This regulates it a bit. Then from here it distributes. That's why we have capacitors around it to make it step down. Then we have this resistor around it. Then from here it now begins to supply. Sorry, it begins to supply, begins to flow, just like that. Then when it begins to flow to this place, then we have what we call that MOSFET or inductor. You understand? Then around it sometimes we have some of this tiny diode also, but majorly it's not common on power banks. You understand? Diode is not common on power banks. So from there we're now moving to output. Moving to output. Moving to output. It just flows to one of the lines here, then it flows to this other line, flows to this other first line, then flows to this first line here. The middle lines are not always needed. These ones are needed, but however, the reason why the two middle line are also important is so that the charging will be smooth and will be fast. Now we need to, from here we'll now move to why charging ports and why this USB charges slow. Do you get why USB charges slow? Because sometimes the flow, now from here the power, if it's coming from here 5 volts to this place, you will not be getting 5 volts. What you'll be getting is, let's say 1.8 volts from this place now, 1.8 volts, sometimes 0.9. Do you understand? So then it flows to this place, then it gives us this charging. Now, if this is 5 volts coming to this place, we have 4 resistors here. We have 4 resistors here already. It's already received some of this voltage. Because if this, listen, if this current flows, if this current flow is coming directly to this power IC, PMIC, it's going to damage this power IC. The reason why some of this power IC get bad, in the case of some of these ITEL 2000, 20,000 mAh, look at this now. This is the power IC. This is exactly the diagram I just drew. Now, if this is the power IC here, and this is the charging ports. This is the USB, Type C charging port. The current flow is coming from here. 5 volts is coming from here. It will not be coming directly to the. It's going to be coming directly to this place without this diode. We have 2 capacitors. Then we have okay, sorry, this is capacitor. This is a capacitor. This is a capacitor. This is a capacitor. This is a resistor. Then we have 3 capacitors around here. Do you understand? This holds the current flow, helps us reduce it a bit before it now moves into this place. We have this 3-legged what's it called? MOSFET. Do you understand? It also takes from it. But look at it. If you are seeing this, how many lines are here? We have 1, 2, 3, 4, 5, 8. 8 lines here now. So 1, 2, 3, 4. 4 lines are for the charging. Yes, it's coming directly to this place. 5 volts, but already it has been stepped down here. So it's coming to this place. If 5 volts enters this one, it will get damaged. So if this thing get damaged, what happens? There is one of these capacitors or fuse resistor that is faulty, or that is short. You understand? So damage to this, to any of this, brings damage to this, because the current, there will not be, the current. One of those things will not be regulating it again. Then those bringing too much load on the remaining 3. The job of 4 will now be reduced to 3, and the same current that is coming from this place, it will be splitted onto, let's say, if 5 volts is coming from here now, this one is supposed to take 1.5, 1.5. Do you understand? Or 0.9, 0.9, 0.9. But one of them is short or is faulty. The current will not be, the current flow that is supposed to come into this place will increase, yes. Then there will be issue. Then if this power IC is having issue, all you need to do is just remove it, because this is the main brain of this module, this power bank module. Do you understand? That's just it. So the problem with this 20,000 mAh power, you can see the MOSFET I was talking about here and also. Yes. So you can see that's just it. Once this thing is being replaced, the job starts again. For that is the input, right? Then also want to I'm seeing something. All right. Sorry. No. When current flows into the power bank from 5 volts, right? 5 volts. It flows to the power IC. The power IC then distributes to the other components around the motherboard. The power IC is the one that regulates it. It is always close to this thing. It's just like the receiver. Here it receives, then distributes. So it has around it we have this one is compressed. You understand? Like there are so many components compressed to it. I mean, in it. So it has the power to distribute. It has the power to regulate. It has the power to retain current flow. But then we have some, like supporting components around it that also helps it to regulate the current flow. You understand? Yes. So is there any other question?
Capacitor, what is it used for?
Yes, talking about capacitor, there are so many things the capacitor does. But one of those things capacitor does is it retains high level of voltage. High level of voltage. I have the video already. I've explained that when I was explaining SMDs and functions. You understand? But I think I will send you the video again. On all PCB. Do you understand? It's not always like this. On some PC, on some module, it's different. The diagram is different. The diagram is different. But the one I'm teaching you, this is more easier to learn. Yes, and this is more easier to learn. So that's why I drew this kind of diagram for you. But however, if it's this or not, if it's this one or the other one, is this still the same? Yes, mode of current flow. It's coming directly, because the reason is that most of these things are not really strong. You understand? So it doesn't have all this DC to DC, all these things. All of them are compressed in that power IC. All of them are compressed. So they just have to there's a part of it that regulates it. There's a part of it that makes it, that sends it out. There's a part of it that that retains current flow and makes it distribute to other components. So it's almost like, that's why they get bad easily. You understand? That's why they get bad easily. And I feel that some of these producers are just doing it for at least to buy.
People will not be buying.
Yes. So it won't get bad. So just anyway, that's by the way.
This output now, because we are trying to charge the power bank.
Yeah.
This output, is it the battery?
No. No. Yes. No. The output is the USB now. Like I said, the USB.
We are trying to charge the power bank. So USB.
No. That's an electrical question. I think that should be asked in your biology class. Anyway, this is it. This is the diagram here. Look at this here. Let me explain again. The USB is usually the output. However, whilst this is the output, there are other components that is controlling the flow of current into the output. Do you understand? So we have the output, the MOSFET IC that controls the output. If this one is having an issue, this will not work. The power bank will be charging, the battery will be charging, but the power bank will not charge phone.
Okay, so the other components that are going to the battery as well as the output. So
not components. This is it. Let me explain to him again. If 5 volts is coming from the charger, so now maybe you are confused with the charger. This is the charging port, right?
Yeah.
This is the charging port, right? Any current that is coming from here now to this charging port is called 5 volts. Now the 5 volts is now coming to is supposed to go into this place, then sent to this other place. All of them is in circle. Now if it's coming to this place, to this power IC, it's being regulated. While it's being regulated, this power IC sends current also to other components. They are now send the current to this thing. Now it's just like a process of input then output. Between the input and the output, we have the power IC then we have the regulatory IC, then we have what we call, let's call it CPU for just, clarity's sake. Let's call it CPU, central processing unit. So from the input here, right, then to the output here, we have, between the input and the output, we have the what we call CPU. Let's say central components that process the current flow. Because if this current flow is still coming to this output, there will be issue to the phone you are charging. You don't need a 5 volts to charge your phone. You need between 2.8 to 3.8 voltage, right, to charge a phone. So it still now comes to this place, and to charge the battery rather. It still now, while the current is going into this place and aim at coming to this output, all these components you are seeing here regulate them, and each of them have the level of current they take and are sent out for this thing to work efficiently. That's why I had to still talk about the reasons why phone charge, USB charges slow on power banks. So did I clarify your question, or you still have any other doubts? If you still have, let me know, so I can still explain it better further. No, if you are confused, let me know, please.
I understand this.
Okay.
But this is my own question is, which one is going to the battery? Since we are charging the power bank.
I already explained it here now. That means we are not following. If the current is coming to this place, this is the battery here. You can see this is the battery. This is the battery plus. This is the battery minus. So the aim of this module is to charge the battery, right?
Yes.
Then the aim of the battery is to charge the phone. Once the phone is the battery is well charged, then the output IC starts to function. You don't expect power bank to be charging and at the same time sending out voltage. Even if it's sending out voltage, at interval you see it short, you see it stop, it is going to have effect on this MOSFET, because it's not programmed to input and output at the same time. You understand? So while this thing is flowing, while there is input here and it's flowing to this battery and it's charging the battery is now aimed at charging the supplying current to this place. But don't forget, while you plug the charger also, there's going to be current flowing to this place. If I should plug directly now on direct current and there's no battery plugged to it, since the current is flowing and it's not going out to any place, it's going to be sending to this place. Then I can charge the phone directly. You get? But once it detects that there is a particular device that is drawing current that is coming from this place, it will stop giving us output here. Do you get it? So it can't charge at the same time. So the both can't charge at the same time. So while it's charging the battery, leave it to charge. Then the battery function is to what? To supply current again. Now then we have DC. We have the AC, alternate current. Do you understand? Then we have the AC, alternate current. Then the alternate current will be 3.8. 3.8 now will now be split to 0.9 to 0.6. 0.9 to 0.6 is what is now needed to charge your phone on alternate AC mode, not direct current mode. What I gave you here is the direct current mode. But on this one, we need 0.9 to 0.6 or 0.6 to 0.9 for output to work, or sometimes 1.8 at most, because every battery will be giving us 3.8 voltage, the current that will be, the voltage that will be restored on it. Do you get it? You understand better now? All right.